Today we're going to be talking about correlation and causation, two things that have to do with the scatter plots that we've been talking about for a day now. So our objectives for today are to further analyze correlation of a scatter plot and to talk about the difference between correlation and causation. We discussed this briefly yesterday, but I want to review when correlation is positive and negative. So correlation is positive when our values increase together. So this one is positive, and I'd love it if you could just draw a quick sketch next to this of what positive correlation looks like on a scatter plot. So let's remember, correlation that's positive, I know this is small, looks like a general upward trend of our data points. And correlation is going to be negative when one value decreases as the other increases. So this is negative, negative. And a negative correlation on a scatter plot looks like this. So we'll have, as our x increases, our y decreases. So we'll have something that looks like this, a general downward trend. So the new thing about correlation today is that we're learning that it has a value. We can place a numerical value on how good our correlation is between our variables. So correlation's value is something we're going to call the correlation coefficient. So correlation coefficient. And this correlation coefficient ranges from -1 to 1. So if our correlation coefficient is 1, it's equal to 1, we have perfect positive correlation. If we were to see a graph with perfect positive correlation, our scatter plot would look like this. A line where our y values increase exactly how much our x values increase. So we have a straight line as our trend line. If our correlation coefficient is 0, we have no correlation. And if you remember, a graph with no correlation means that there are just points scattered everywhere. There's no upward or downward trend. And as you might guess, -1 is perfect negative correlation. So that scatter plot would look like this, with a perfect trend line going through our decreasing values. So in our first question, we have a graph that shows us the relationship between the number of missed classes and exam scores. So we are to determine which correlation coefficient given to us best fits the graph. So we have to choose between one of these 4 correlation coefficients. So my first step would be to identify whether my correlation is positive or negative. Here, our trend is generally downwards. So we have a negative correlation. So I might draw a line right through it like that, see that we have a negative correlation. And if we have a negative correlation, we can automatically eliminate 2 of these, the positive ones. So we're only left with negative correlation coefficients. Now, we have to choose between -0.7 and -1.0. If you remember, -1.0 is perfect negative correlation. That means that all of our points should line up exactly on that trend line. That's not happening here. So -0.7 is still pretty good. -0.7 is fairly close to -1, but it allows for a little bit of wiggle room around that trend line. So I'm going to say that we do not have perfect negative correlation, and I would choose A. I would say the main takeaway that I want you to take from this video is that correlation does not imply causation. Let's talk about what that means. So this guy right here is causation. And what I mean by that is that even though 2 variables might be correlated to each other, so even though one may increase as the other increases, it does not mean that one causes the other to increase. Let's look at an example. So here we have a graph that shows us the relationship between the temperature of a day and the number of rescues made on a beach. So the number of people who had to be saved from drowning. So if it looks like as the temperature goes up, the number of rescues made on a beach goes up. So I would say that this definitely has a positive correlation. You can see that I can kind of draw a trend line through this, going that way. But does this mean that the temperature, the hot temperature, causes people to have to be saved? Does this mean the temperature causes the number of rescues made on a beach? No. What our graph is telling us is that temperature is correlated to the number of rescues. But you have to think hard about whether there's a missing variable in there. So is it temperature that causes the number of rescues on a beach? Or is it something else? Is it maybe the fact that the temperature means there are more people on the beach? And when there are more people, there are more chances for people to be rescued. So maybe the missing thing here is that temperature does cause something, but it isn't the number of rescues. So let me say that again. The temperature might cause more people to be on the beach, so more people. And then more people on the beach means there's more of a risk of somebody having to be saved. So that might be what causes the number of rescues. But I want you to remember that just because you see correlation on a graph does not mean that one of your variables causes the other. All right, I will leave you to try the problem at the bottom of your guided notes, and thank you for watching.